Hello, this is Donovan. So, unfortunately, I couldn't be there in person today to give this presentation, so I decided to record a little video to show off some of the stuff I've worked on this semester. So, I'm going to start by talking about other projects and assignments, and then I'm going to finish off with my design project. So, this is my submission for assignment number 2, the building design. As you can see, I modeled it after SpongeBob's Pineapple House. I had a lot of difficulty with the leaves at the top, as you can see, but apart from that, I'm pretty happy with how this one came out. I think I got the proportions mostly accurate-ish, kinda. So my house has this sliding glass door, and sometimes throughout the year we'll plug in this AC unit for when it gets too hot or too cold, but this bracket is very small, and therefore requires this big foam panel to fill the rest of the space. But the problem is there's this kind of big gap here, which lets a lot of cold or I guess warm air leak through. And so I designed this piece in Fusion to fill this gap. You can see it's got two little posts on the bottom which fit into the top of the bracket here. And it's got this long slot on the top where the foam slides in. And yeah, you can see it works pretty well. It's got a little channel here for the cord to pass through. I had to print it in two parts actually because my printer is very tiny, but you know, it doesn't need to be pretty. It works fine for what it is. So lately my girlfriend's been really into knitting, and she uses these hoops to do it, and she was bummed because she didn't have a hoop small enough to do like, you know, mittens or socks or whatever else. And so she sent me this reference image and asked if I could print her like a tiny hoop to make socks with. So I modeled this from scratch in Fusion. Here's pictures of it printing, and it worked great. Unfortunately, I don't have any pictures of the finished product except for this one, wherein one of the pegs snapped off because her cat sat on it. So I'm going to reprint a new one with higher infill percentage, so that doesn't happen again, hopefully. Alright, so now I'm going to talk a little bit about my design project. So here, I don't know how well you can see it, but here's my just super rough sketch of what I wanted to look like. So basically my design is this bendable reading lamp that uses an arm made out of this single interlocking vertebra tiled a bunch of times. Here's my first prototype for what I wanted this vertebra to look like. So basically you can see it's got a male end and a female end, and these holes allow a bolt to be stuck through the side there and attach these together. But unfortunately I messed up the measurements, so you can see the design intersects with itself, and I didn't want to push this hole further down because I was worried this would be too thin, and I filleted these edges almost immediately, which made it really difficult to work with this model, and so I decided to just scrap it and start over the next day. So here's my second design. It's more in the style of the final product, which I'll show you after. But you can see I went for a much more kind of brutalist, like right angle look for this one, which I'm pretty happy with. This one worked great, just laying it out in Fusion. It looked really nice tiled together, and it totally seemed like it would work, so I printed a prototype, and it came out great. You can see I've got my pieces here, I've got this bolt stuck through, but I realized there was an issue with this design, in that if you tried to tighten this bolt to tighten the fit between the two pieces, it wouldn't actually, you know, make these gaps between the pieces smaller. It would just put stress on these two arms, causing, like, you know, bending right here. This part would get compressed. It's just a mess. And so I remodeled it, and by that I mean I just removed one of the two arms to create this sort of lightning bolt shape, which I'm super happy with. You can see it fits together really nicely. It looks really great, and I've added on a little loop to hold the cord of my lamp so that's not flying everywhere. And yeah, here's some other parts that I designed. Basically, this is the top of the lamp that I had to work with. And so these two parts, which are the lampshade and the collar, which attaches the lampshade to the vertebrae, they both use this big threading to attach themselves to the top of the lamp kit that I had. And you know, it wouldn't have been so tough if I were modeling all of the threading from scratch. But the thing is, I had to create threading to fit into an existing threading, which was terrible. It was so difficult. This took me 3 attempts And on my third attempt, you can see I got it to work right, except I had to basically cut open my little fit test here to be able to fit it around the thing, so it didn't actually work. But you can see the threads are interlocked with each other, which was super promising, so this gave me kind of the information I needed to model this thread in the right size. So yeah, here's my final design. I'm super happy with how it came out. I used proper metal hardware to attach the pieces together, and it's kind of hard to see. I didn't get a great picture of it, but there's little rubber washers in between each piece, so that when I tighten down these parts, the pieces aren't, I guess, tempted to like slip and slide everywhere. So you can bend this arm and it'll hold its shape even under the weight of the lamp and the other pieces, which is pretty cool. The whole unit is super heavy, it's super sturdy. You know, I'm really happy with how it feels and looks and everything. And here's a shot of it lit up. I love the warm kind of yellow glow from this lampshade I made, and yeah, I'm super happy with how this design came out. I still have a little bit more work to do that I couldn't get done in time for this presentation, in that I have to figure out some kind of base system for it. Currently my plan is to make like a clamp that'll attach to my desk, but that's a problem for future Donovan. For now, I want you all to bask in the glory of this awesome lamp that took so long to make. Every one of these vertebrae was about 5 or 6 hours of print time, and that's not counting all the times that they failed, or, you know, I printed them and realized there was something wrong, so I had to remodel it. But that's it. Thank you so much for listening. I hope you enjoyed. I look forward to seeing all of your presentations if I'm able. It was great getting to know you all this semester, and I hope I see you all in the future. Bye-bye.